Okay, so what we're gonna do for today is we can talk about the solution to some of these questions that were given to you last week. So we can go through this together as a class. We can make it, discuss this so that we can get better prepared for our test because our test is on Wednesday, right? So let's go ahead and talk about this one here. Question 1. Explain the difference between accuracy and precision. Because for the most part, accuracy and precision sounds like they're pretty much the same thing, but they're in this context, in this discussion, accuracy is different from precision. Okay, so the word accuracy actually, I'm gonna do that in here. Solution. Accuracy talks about the closeness to the actual measurement. Talks about how close we are to the actual measurement, whereas precision talks about how fine, and how fine the measuring device, okay? And the relationship between these two is that if we use a high degree precision instrument, then our accuracy would be high as well. So our precision, when our tick marks are more frequent, then we could have a higher accuracy in the measurement. So the precision talks about the device, whereas accuracy talks about how close the measurement is to the actual measurement. Okay, so that's those two. Question number 2. There is a picnic table in a park that measures 12 meters in length. Oh, okay, so that's a very long picnic table, right? 12 meters. So if you think about this is a really huge table. This is 1 meter. So if you have 12 meters, that's a long picnic table. It's really a very 12 meter in length. Peter measures the length of the same picnic table using his forearm. He says that the picnic table is 12.4924 arms long. Is his measurement precise? So the answer is his measurement precise? No. Because when we think about it, the forearm, right? It might be that's measuring device that he's using. It's not precise enough. It's not precise because it doesn't have the fine measurement that we need for a precise device. So no, because his forearm, okay, this is a really funny. That's a really funny question. Because his forearm does not have the tick marks for finer measurement, right? Because when we talk about precision, it's figuring out how fine the measuring device is. And if he's using his arm, his arm doesn't have that fine measuring measurement or tick marks on his arm. Letter B, is his measure accurate? Is his measure accurate? So in this case, yeah, we can say, yeah. Because if somebody says it's 12.492 forearms long, that's a good enough measurement, pretty close measurement to the actual length of the table. So yes, because the actual measurement of table is close to the measurement he got using his forearm. So when you look at this, it's pretty close to the actual, okay? It's not going to be the exact measurement, but it's close enough to his actual measurement of the table. Okay? Is that okay? So that question is actually kind of defining the difference between precision and accuracy. Precision and accuracy. Now let's take a look at question number 3. Question number 3. I'll read it first and then we'll see. So what are the precision and uncertainty of the following measurement? Show your answer using the measurement plus or minus uncertainty. So let's take a look at letter A, 3A. 2.5 kilometers. So 2.5 kilometers. In this case, we don't have a measuring device to see the precision. We don't see how fine the measuring device is, but a way to figure out how fine the measuring device is the lowest or the smallest number that we could get in here. So 2.5 kilometers. So the finest one is a 10th place. So that's going to be a precision is 0.1. 0.1 kilometers. Okay, so that's the finest one. The smallest measurement is the 0.1. Yeah. And then the uncertainty, because now that we have the precision, we can figure out the uncertainty, and uncertainty is half of the precision. So once we have the precision, just half that, and then you get your uncertainty. So it's going to be 0.1 divided by 2, which is 0.05 kilometers. Now that we have those information, we can write it as measurement. We're supposed to write it as measurement plus or minus uncertainty. Okay. So the measurement is 2.5 kilometers, so 2.5 plus or minus uncertainty is 0.05 and everything is measured in kilometers. Okay. Letter B. Letter B, 1.84, sorry, not 1.84, 184 centimeter. Okay. The finest measurement is the smallest unit that we could get, 1, right? The precision is 1 centimeter. So uncertainty, I'll just put U for uncertainty, is half of that, which is 0.5 centimeters. Now, if we were to put that in the measurement plus or minus uncertainty, it's gonna be 184 plus or minus 0.5 centimeters. Okay, is that good? Take a look at letter C. Last one for letter C, it's 405.33 kilogram. So again, we don't have the measuring device that they used to measure this weight, this mass, but we know the finest it went is the 100th place. So that's gonna be 1/100th. You can see it's 2 decimal places, so its precision is 0.01 kilogram. And then uncertainty would be half of that, so 0.005 kilogram. Now putting it all together, it's going to be 405.33. So that's the measurement. That's the measurement in kilogram, plus or minus 0.005 kilogram. So that one is good. So when we're writing this down, you know, if you want, do it step by step, figuring out the precision first, and then once we have the precision, take the half of that, that's our uncertainty, and then write it as a measurement plus or minus uncertainty. And we're not going to forget, we're going to remember to put our unit each time. Okay. Is that good? So we'll go to number 4, question 4. Okay, I'll read the question first and then we'll figure out how we can go about this. It says Ahmed is a shipping and receiving clerk at the warehouse. He is preparing boxes for shipment to a customer. In one box, he packs 2 items weighing 11.3 kilogram and 5.6 kilogram. What are the uncertainties of each of the items? And then what is the combined weight and uncertainty of the items? So what we're going to do is, first of all, we're going to do the uncertainty of each item individually and then the combined. So letter A. So the first one is 11.3 kilogram and the other one is 5.6 kilogram. So the precision first. Let's start with the precision because once we get it, and then it's easy to have it. So the precision, the finest measurement that we have is 1/10 of a kilogram. So 1/10, that's 1 decimal place. So 0, maybe I should put that there. 1/10. So 0.1 kilogram. Therefore, uncertainty is 0.05 kilogram. Okay. Now this one, pretty much the same thing. Precision is 1/10 of a kilogram, so 0.1 kilogram. Uncertainty is also half of that, which is 0.05. Okay. At this particular point, is everybody okay? Is everybody okay? You okay? Yeah. So looking at the finest place value, 1/10, so it's point. Okay. So it's 0.1. That's A, and now B, the combined. So if we were to combine them, okay, it says here, what is the combined weight and uncertainty of the items? So we could certainly combine the weights. That's pretty simple, right? So we can combine them, put them all in one box. What is it? So that becomes 11.3 and then 5.6. That's going to give us 16.9 kilograms. So that one is not bad. Okay, we know we got two items, this much and this much weight. Now we are supposed to write down the total uncertainty. Well, we have uncertainty in this first item. We have a certain of uncertainty in this second item. So together we can combine the uncertainty. So combined uncertainty is would be 0.5 and another 0.5, 0.05 rather, 0.05, so 0.1 kilogram. Okay, so we can write it like that, or we can write it as 16.9 plus or minus 0.1 kilogram. Okay. So far so good? Any questions? Okay, now we're going to take a look at question number 5. Question number 5. Let's see. An oven measures the temperature to the nearest 10 degrees. Okay, oven measures temperature to the nearest 10 degrees, and it says 160. What is the precision and uncertainty of the oven's precision and uncertainty? So, and if it says here, measures, it measures to the nearest 10 degrees Celsius. So that's what it measures the finest measurement is. So the precision in this case is 10 degrees Celsius. Okay. And the uncertainty would be half of that. So uncertainty is half of that, so 5 degrees Celsius. This is letter A. The next question is, what is the maximum temperature and the minimum temperature of this oven? So because we have 160 degrees plus or minus the uncertainty, which is 5 degrees Celsius, so that really means that when we read 160, it's a give or take 5 degrees Celsius. So give or take 5 degrees Celsius. So maximum is 160 plus 5 degrees is 165 degrees Celsius. And then the minimum would be 160 minus 5, which is 155 degrees Celsius. Okay. Just because it says there 160, it may be a little bit over or a little bit below, depending on the precision and the uncertainty of the device.
Or you could write that as 160 plus or minus 5 degrees.
Oh yeah. So yeah, you can see 160 plus or minus 5 degrees. But if they ask for what is the maximum, we should write down 165 and then 160 minus 5 for a minimum. Is that okay? So far so good? Let's look at number 6. Let's read it first. Processing facility packages a flour. A 10 kilogram sack of flour must be within a tolerance of 0.5 kilogram to be acceptable for sale. Now this one here is now giving us the tolerance of 0.5 kilogram for acceptable value for sale. What is the acceptable range of weights for each bag? So figuring out what's the maximum and minimum allowable weights. So if we can, this one here, the thing about this way is we have, I like this because it has a visual for us, right? So we know that this flour has to be in a package of 10 kilogram. Okay, 10 kilogram package, right? So that's our target. That's our target value. Now we could vary it slightly. And it's still acceptable. We can go a little bit over, we could go a little bit below, but it's still acceptable. Okay, so they said the tolerance. So that means the full tolerance is 0.5 kilogram. So the full tolerance is 0.5. So that means we can take half the tolerance to go to the minimum and then half tolerance to go to the maximum. So if the full tolerance, full tolerance means how much is the difference between minimum and maximum, is 0.5. So this is going to be 0.25. And then this is 0.25. So this is our target value, target amount, right? But the full tolerance is 0.5, so it's half of the tolerance would be 0.25, and then half there. So what is the minimum? Minimum would be 10 minus the 0.25, which is going to be 9.75 kilogram. So it's okay to be 9.75 kilogram. That is still acceptable. Or a maximum of 10 kilogram plus 0.25, so 10.25 kilogram. Okay, so the full tolerance is 0.5. So if you look at the spread between minimum and maximum, that's 0.5 of a difference. Is everybody okay? Let's go to the next page. Next page, number 7. I will have this posted. Number 7. Number 7. Let's read it first and then see from there. Okay. The diameter of a drill hole for a dowel joint is specified as 1.524 centimeter plus or minus 0.012 centimeters. What is the maximum and minimum acceptable diameters of the drill hole? Okay. And then letter B is, we have this measurement and we're going to try to figure out if it's acceptable or not, yes or no. Okay, so let's figure that out first. Letter A. We know it's 1.524 plus or minus 0.012. So this is the measurement, and it's okay. Okay, so this is the measurement. And then they said it's okay to add 0.012 centimeters or a little bit less. So let's figure out the minimum first. So 1.524 take away 0.012. So the minimum would be 215. The minimum is 1.512 centimeters. Let's figure out the maximum. The maximum is 1.524 plus 0.012. So that's going to give us 6, 3, 5. So that means the measurement has to be between 1.512 and 1.536. So let's have a visual in here. 1.512 and then 1.536. These are within these two values, minimum and maximum, that's allowed. Okay, now let's take a look over here. I'll do letter B. 1.5241. Is that allowed or not allowed?
No.
It's not allowed, right? Because that's 1.5241, and that's over the maximum allowed. So that's a no. The next one would be 1.5119. 5.119. Well, we got 3 decimal places in here. 5.511. That's less than that. And even if we add the 9, that's still less. So that one would be a no still. Okay. Letter C, 1.532. Is this within the range of acceptable values? Yeah, 1.532. So less than this, but over that. So that's yes. 1.540. Is that within the acceptable limit? 5.40. I got 5.536. No. So that's a no. 1.5355. Yeah, so this is a yes. And then 1.537. That one definitely is a no. Okay. So we can see which ones are not going to be accepted and then which values are going to be accepted. Okay. Number 8. Number 8, a bolt for an airplane wing. I'll read it first. A bolt for an airplane wing is supposed to be 5.22 centimeters plus 0.006 minus 0 in length. Okay, I'm going to explain that for a second. So 5.22 plus 0.006 minus 0. So this means that it's okay to be a little bit over, but it's not okay to be less. Okay, so it's okay to go up to plus 0.006, but it's not okay to be below. Okay, any more below. So list the nominal value, maximum, minimum, and tolerance for this bolt. So first one, nominal value. Nominal value would be, what are we hoping to get? We're hoping to get 5.22 centimeters. That's our target, our nominal value, our target value. Now we're trying to figure out the minimum value. What's our minimum value? Well, 5.22 take away 0. 5.22 take away 0. That will give us a minimum, which is still 5.22. What's our maximum? Maximum value is 5.22 plus 0.006. So maximum is 5.22 plus 0.06. So that's 5.226. And I should remember to put the unit, centimeters. Now, what's the tolerance? Okay, now let's see if we could figure out the tolerance from here. Minimum is 5.22. Maximum is 5.226. So full tolerance is how much is the spread from minimum to maximum. that's going to be full tolerance. It's going to be 0.006 from minimum to maximum. So tolerance, okay, what's the difference between these two? Maximum 5.226 minus 5.22, 0.006. So if you want to put this on a formula sheet, the tolerance is maximum minus minimum. That's a tolerance, maximum minus minimum. Okay. List the 3 other ways. Okay, well, list the 3 other ways of writing this. This is continuation of number 8. Okay, so the different ways of doing that is nominal value plus or minus half tolerance. Half tolerance. Okay, so how do we do that? Min, max, 5.22, 5.226. If we look at this one here, it's plus or minus half the tolerance. So this tells us that the nominal value, our target value, is halfway between maximum and minimum. So halfway of the maximum and minimum. So that would be, we know that the full tolerance is 0.06. So that means this is 0.03. And then this is 0.03. So that becomes 5.223. So if you add it by 0.03, you're going to get that. And if you add another 0.03, you're going to get the maximum. So is this one okay? So if it's in this form, that means our target value is halfway between max and minimum and maximum.
.22 plus 0.03 is 5.
Oh, shoot. No. It's supposed to be 0.6. Yeah. There you go. Thank you for fixing that. I forgot another 0. 0.006. 0.006. Okay, is that good? The other one would be the nominal value plus tolerance minus 0. I think that's the one that they already have in here, right? Nominal value, our target value. That means you can't go any lower. You can't go any lower. So that means our nominal value this is now our nominal value. Nominal value And this is 0.006. I should put 2 zeros there. Okay. So to go from minimum to maximum, so nominal value, right here, this is our nominal value. We're gonna add the fault tolerance to get to that part. And then we can't go any lower, so that's where we are. This is the one that we're doing right now. This is the one that we're doing right now. We're on number 8. Oops. Okay. So the first one, the nominal is in the middle. The target value is in the middle. This one here, the target value or nominal value is at the beginning. Now what if the nominal value is at the end? Okay, if the nominal value is at the end, that means we have to add 0 because we can't go on any higher. So plus 0 minus the full tolerance minus 0.006. So this is what it would look like. Nominal value of 5.226. And then 5.22 is our minimum, 0.06. So this is our target, 5.226, but then it's okay to go lower by 0.006. Okay. And then the last way would be just writing down the maximum. This is the easiest one. Just writing down the maximum value and the minimum value. So maximum is 5.226 and the minimum value is 5.22 centimeters. So moving the nominal value around. The nominal value could be in the middle, the nominal value could be the minimum, or the nominal value could be at the end. Or just plainly saying max, min values. Is that okay? Now, number 9. Number 9, last but not the least. Number 9, Kelsey is a welder. Kelsey is a welder. She needs to preheat a section of steel before welding to reduce the risk of cracking. She has to heat the steel within this acceptable range. So these are the acceptable range of temperature. What is the tolerance? What is the nominal temperature? And then rewrite the temperature as a nominal value plus or minus half the tolerance. So 275 degrees Celsius, 225 degrees Celsius. So they're telling us the minimum and maximum. So if you want, let's go do the minimum and maximum. So this is our minimum, maximum, minimum and maximum. From here, what's a full tolerance? So what is the spread from, what's the difference between minimum and maximum?
50 degrees.
50 degrees, right? So full tolerance would be 50, right? 225 and 275. That's 50 degree difference, Celsius difference. Now, if we want, if this is the full tolerance, so that means this is half is 25, half is 25. What's in the middle? This one would be 225 plus 25, so that's 250. So that's how we are gonna write it out, because we want nominal value plus or minus half tolerance. So letter A, what is the tolerance? So the full tolerance is 50 degrees Celsius. That's a full tolerance. What is the nominal temperature? The nominal temperature would be the 250. And then letter C, we're supposed to write it as a nominal value plus or minus half tolerance. So our nominal is 250 plus or minus, give or take. What are we going to give or take? Half the tolerance. Half is the 25. So 250 plus or minus 25 degrees Celsius. Okay. Well, how do you feel about that? Is that okay? Okay. So, our test on precision measurement is on Wednesday. Okay. So our test on precision measurement is on Wednesday. So tomorrow, if you have any questions, you can ask me.